Oh, good morning. My name is Takanori Arima. Come from Japan, especially come from Miyazaki. It's very, very important words. My presentation is wood engineering in Japan and past and future. Yes, one is wood and forest in the environmental protection and resources cycle. It's very important concept, my presentation. One is how to protect the environment, especially global environment. And now is sometimes greenhouse effect and so on. And another one is renewable resource. That means in sustainable development. And 2 points is very important. One is, as you know, is greenhouse effect, such like this. Temperature on Earth is going up. That means is increasing carbon dioxide. Sometimes that is another word. Another word is very important. Decreasing energy resources in the earth is very important. So we have 3 benefits by using wood. 3 benefits. One is carbon storage effect. Sometimes in forest, in zinc, in wooden building is carbon stocks. Yes, that is forest in the cities. Timber structure is in the cities, urban forest. And second one, energy conservation effect is timber is significant less manufacturing energies, very few. Sometimes 10 times or 20 times, sometimes 100 times. Very, very few. Another materials is very lot of energies. And third one is alternative energy effect. As you know, timber is a fuel. Incineration of material. That we have 3 effects, 3 benefits by using wood and timber. That is very, very typical data. Carbon release for producing to make materials. For example, air-dried timber, 30 release for energies for producing, and private about 7 times, but another steel is about 20, and aluminum like this. Incredible difference in the saving energies. And another one is very important is carbon stock. Carbon stock is timber includes the carbon. Photosynthesis is carbon stocks. So if we used in timber structures, stock is bigger than carbon release. So, this meaning is another forest in urban. After demolishing the houses, this carbon stock is for fuel. Sometimes another materials for particle board and fiber board and so on. That is very important factors. So, using wood lead to producing resources. That means we used in the forest and cut it and stock the house or some furniture and so on, and demolished and recycling, but finally is burning back to forest. Oh. But in forest, get sunshine to newly renewable resources. Another materials, for example, what steel or mineral and so on, is just only to release lasting. So we say this circle is very large circle. That means producing resources, including producing resources. But another, recycling, sometimes we say recycling is very important. But this is very important. But this circle, recycling system, no producing resources. This is very, very important differences, another material, timber and another material. So I show you some example. Timber dome in Miyazaki City. It is make it Japanese cedar, very straight. Typical Japanese planted trees, man-made planted trees. It's very first grown species. This one is span, long span 122 meters, short span about 1.2 meters, and the height 36. This one is made of timber structure. Specific gravities of sea, specific gravity about 0.35. Very light. This one is timber dome in lamina. It used lamina about 2,000 cubic meters. This one is stock, carbon stock about 22,030 carbon. And using the energies, if use this timber structure, this one timber structures, is compared to steel structures. I think this one is half steel structures. This dome, this one is, this position, this joint is made steel. Made steel, I'm afraid. And this one's glulam. If it's a steel construction, this one's steel, maybe same weight we can, but 10 times energies are used. So, this one's 10. If steel construction, 10, and 10. So that is half. It's half energy used. So another one is very important. This dome used is Japanese cedar, man-made forest, from man-made forest. So we use this timber. So they planted there about 10 hectares replanted. In the urban areas, in the stock, in the cabin, and in the forest is another newly planted Japanese cedar is started. That is 3 benefits. It's very important. So, in forest in Japan, its area is stable. Now is very stable, like this. About 25 million hectares, and man-made. This blue one man-made forest. This one natural forest. This one is stock. In Japan, is stock in mainly by is man-made forest. So we have to use that reason. Distribution of age man-made forest in Japan now is red one. Its young is very, very small. But 1963, when I the student, like this. Very changeable. So that time when I student is not so suitable to use. Now is we can use suitable to use now. So we have to cut and renew is required. That is very important Japanese forest policies. And another one is demolished wood is resources, is urban, not waste. It's very another important, but this time is not so enough to present. Very important. Third benefit, like this. So I will show you in Japanese situation with timber structure. In Japan, the timber structure for residential house is about like this. Very lot of timber structure we have. Conventional wooden construction and light frame construction introduced from in 1974, and industrial wooden house and log house and heavy timber construction like this. This one very traditional, Shiomatsu Sensei already showing timber. This one traditional timber structure. Very different conventional. Conventional is very fit to present time. conventional means. Conventional timber structure generally very flexible. Light frame construction, I can use very easy. And now it's combination traditional log. This one is hotel. In this one is very traditional joint. And this wall is log construction. In Japan, combination is very, very useful to think. Heavy timber construction. Now, I'd like to current drastic change in wooden building, wooden structures. Another, yes, timber structure is very, very long history, but I say it's very important. Timber engineering. So I have to say is about 30 years ago, 2 years ago, is past for me. And one is timber engineering impact by research project. For example, 30 years ago, I engaged in the Building Research Institute. Building Research Institute government. But that time, only one timber engineering researcher, only one. But now is a lot. Architectural Institute of Japan, presentation, that time 2 or 3 topics. Now, this year, about 300 topics. Very changed. Only 30 years. And second, and precast system for conventional timber construction is drastic change. Carpenter is very lack of carpenters, so we have to machine cutting and so on. And third one, 1995 Southern Hyogo earthquakes, big natural disasters. This one is related to such research increasing very, very. This one effect, earthquake damage is reflect to number of researchers, very, very increasing. And third, more promoting timber engineering. I show you in detail. For example, this one is 3-story semi-detached dwelling. In the full-scale test is a lot. And Japanese building codes requires very severe fire protects. So full-scale test is needed. And 0-story apartment houses. That is very research works in stressed to timber engineering. And second one, precast system for conventional timber construction. This means old machine cutting method for conventional timber structure. So-called precast system is combined with the computer and design. That method is very effective. This one's like this, precast conventional houses. this is for carpenters. And this one's industrial houses. That is, this machine cut method is to reflect, is selecting of material, selecting of building material, very changeable. For example, is dry, kiln dries timbers and glue them and required. Conventional timber structure like this. It survived 1995 Southern Hyogo earthquake. I think in China is not so severe in the earthquake area, not so. In Japan it's like this. This one city hall and apartment house like this. That earthquake, we have a lot of instructive announcement that in damage result in old houses is crashed, heavy roofing house crashed. That is no. Most of mass media, old one is crashed. Heavy roofing is bad. All mass media is said. It's from aspect from timber engineering, it is wrong. Very important things, this well designed, well built, well maintained timber housing suffered no damage. This is very important. Well designed, well built, well maintained. This is engineering. Japanese traditional timber structure like this. Horyuji temple saw, well maintained, well built, well designed. Engineering is very important. So, after the earthquake damage, a lot of full-scale tests on the shaking table, like this. The brace is breaking, and many full-scale tests and element, or like this element, is carried on now. So now is in progress in timber structure in Japan. That promoting timber engineering is the principle based on performance requirement standard from 1995. Different timber structure, that is, spans full-scale wooden building, various type of building, and the usage of timber. That means very, very attractive, but very hard to meet the requirement, This one's Japanese cedars, whole truss structures. That is very important. Timber engineering, from aspect of from engineering, is very important one. How to strengthen this member? and joint. Strength is what strength that is head. And second, especially classification of log and classification of timber from just standard and so on. Classification of log. This one is classification of log in hitting the hammer and measured frequency. And these logs, how many modulus of elasticity? The result of modulus of elasticity we have to select, and how to make a sawn lumber, how to use glulam, laminar, or so on. For example, this one is modulus, distribution modulus sawn lumber in log. It's outside in the pith part, like this, in Japanese cedar. So we have to, sawing method is very changeable. How to use, how to glulam. And very, very fundamental data is very important. Large scale span, large scale dome, and so on. This one's clip test. Very, very hard works. Dead weight here, and measure the deflection. Time dependent. Time dependent behaviors is very hard. I think is clip on human people. Very important. Fundamental data is very important. Especially timber is very unknown factor. It's a lot of unknown factors. So we have to carry out to get the fundamental data. Like this one, Mechanosofty effect. Drying method is very important. If use green wood, like this, so we have to, drying method is now improved. Time-dependent behavior very is important. Such a building is large span, is very, very dangerous. If we don't know the time-dependent behavior, is very, very severe condition. And this one is wood bridge. This wood bridge is made of Japanese cedar, also same. Like this. 140 meters. And glulam used to logs 4,100 million cubic meters. This one is forestry, about the same in 10 hectares, about 10 hectares. Its stock of carbon is 25 tons. This project is very important. In fact, very important one. Most of people visit here how long will be left? That is what you say in Japanese is not so good questions I answered. This project is very important. How to maintenance, how to rebuild, how to repair, this project is very important. To get such a result, we have the cooperation. A lot of people's cooperation is needed. For example, is this village, it's a very, very small village. Diary aspect is very, very important. And for our laboratory is land, car on land, and 2 measures per years. And manufacture is required, and maintenance method is required, and so on. Yes, this one is same concept, I think. Same concept. But I think material difference. We have to next generation to transfer the next generation, how to transfer our engineering and concept. And the last one, this forest prefectures very, very common sceneries. From grandfather, this planted this Japanese cedar, maybe grandfather. To grandson, this forest cut it. This already planted here, like this. This forest owner is mine. Sunday and Saturday morning, I to cut the grass, and I have to grandson. I work hard. 103 years old tree like this in Japanese cedar. Start is not this one. We have to start. We have to start. How to use. So, conclusion. My presentation is more forests, more trees, more timbers, but very important things, appropriate use. How to use, how to maintenance, how to plant. That is very important. This one, my office, building research, Miyazaki utilization centers. It's made of timber, Japanese cedar. Yes, Japanese cedar. World Conference on Timber Engineering, 2008. Next year, will be held in Miyazaki, in Japan. We are welcome. We are welcome. Anyway, biomaterials as a symbol for the peace. Thank you for your attention. 谢谢. Thank you.